How can we solve exponential equations by expressing each side of the equation as a power of the same base? Let's start with this example. 2 raised to the power of x equals 32. First, we rewrite the equation in the form where we have the same base. So we can write 32 as 2 raised to the power of 5. So we get 2 raised to the power of x equals 2 raised to the power of 5. This means that x equals 5 and we are done with this problem. You can check your solution by plugging 5 into the original equation. 2 to the 5th equals 32 produces a true statement. Let's say we have 2 raised to the power of 2x minus 7 equals 16. Again, we rewrite the 16 with the same base as the term on the other side of the equation. So 16 is equivalent to 2 raised to the power of 4. When 2 raised to the power of 2x minus 7 equals 2 raised to the power of 4, then 2x minus 7 has to equal 4. Note that this works only when the base is greater than 1. After adding 7 to both sides, we get 2x equals 11. And after dividing by 2, we get x equals 11 over 2, which is 5.5, and we are done with this problem. What about 27 raised to the power of x plus 2 equals 9 raised to the power of x minus 3? 27 is equivalent to 3 cubed and 9 is equivalent to 3 squared. So we can write 3 cubed raised to the power of x plus 2 equals 3 squared raised to the power of x minus 3. Recall that the power of power rule for exponents says that we multiply the powers. So we get 3 times x plus 2 equals 2 times x minus 3. And with the distributive property we get 3x plus 6 equals 2x minus 6. After subtracting 2x from both sides, we get x plus 6 equals negative 6. And after subtracting 6 from both sides, we get x equals negative 12. And we're done with this problem. What about 5 raised to the power of 2x minus 5 equals 125? 125 is 5 cubed. So we get 5 raised to the power of 2x minus 5 equals 5 cubed. So 2x minus 5 equals 3. After adding 5 to both sides, we get 2x equals 8. And after dividing by 2 on both sides, we get x equals 4. And we're done with this problem. How can we solve 8 raised to the power of x plus 1 equals 4 raised to the power of x minus 2? We can write the 8 as 2 cubed and the 4 as 2 squared. So we get 2 cubed raised to the power of x plus 1 equals 2 squared raised to the power of x minus 2. So we get 3 times x plus 1 equals 2 times x minus 2. And with the distributive property, we get 3x plus 3 equals 2x minus 4. After subtracting 2x from both sides, we get x plus 3 equals negative 4. And after subtracting 3 from both sides, we get x equals negative 7, and we're done with this problem. Note that most exponential equations cannot be rewritten so that each side has the same base. Here are 3 examples. 4 raised to the power of x equals 20. 7 raised to the power of x equals 32. And 10 raised to the power of x equals 130,000. Using logarithms is extremely useful for solving these kinds of equations, which I will show you in the next video. So stay tuned, and if you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.